Hi everyone, I hope you're doing well. This is going to be my presentation for Lab 4 for Physics 2211. For this lab we were working with circuits, and there's no coding this week. It's just the experiment that we did in GPS, which I'm sure you all did as well. Okay, anyways, let's get into it. So what we're doing here basically is just we're utilizing the principles of current and energy conservation through some criteria that we set using the Kirchhoff's loop rules, as well as just the basic definition of a steady-state circuit. And our idea here is just to see how circuits sort of react and work and measure certain values like current, etc. But specifically, we want to see how RC circuits work with ohmic resistors and capacitors. So we're going to connect like a light bulb to an RC circuit and to a capacitor. We're going to see what happens. That's in part 2 of the experiment. In part 1 of the experiment, we're just going to work with a normal circuit with batteries, resistors, and our multimeters, right? And so you can see here a preview of the results. And generally speaking, our expected values that we got from our calculations, just by applying the formulas to like the known quantities that we had. So for example, we know what the resistance of the resistors is. Just the expected values that we got from that were pretty close to what we actually measured using the physical multimeter, which is a good sign. So let's get into that. As I already mentioned, there are the basic physics principles here. There's nothing too crazy going on. You can see the diagram here. It sort of covers most of it, of what the actual experiment is, as well as some of the formulas. But generally speaking, we're working with Ohm's law, the conservation of energy and charge, RC circuits as a concept, steady-state circuits, the node rule, and Kirchhoff's loop rules. All of this stuff is important here for this week's experiment. Some basic assumptions about the model, not too many. We're assuming that there's negligible resistance in the ammeter slash the voltmeter, I guess, because we use multimeters to record both voltage and sort of a current. So we're assuming negligible resistance in that, although that's probably not the case, honestly. There's probably some level of variance, but we can't really predict for that. We don't know how much that is, so we're just assuming negligible resistance in our model, in our prediction. Secondly, we're expecting all the components to be reasonably accurate to the marked values that they have. So if there's a 10 ohm resistor, we're expecting that to be exactly 10 ohms. And that's often not the case in the real world, especially when you're working with like maybe older lab equipment, for example. There might be some deviation. It's never too crazy. It's like, okay, it might be like 10.5, something like that. But that's still a noticeable difference that could come. That's a possible error that could come, right? But more or less, these are the assumptions that we're making, and the predicted result shouldn't deviate too much from the actual result, which is what happened, right? So the experiment. We make an RC circuit using 2 ammeters, 2 1.5 volt batteries, and 2 resistors. Our predicted value when we plugged like all our values in and expected what we expected the current to be basically was this 0.02041 amps, and the actual value that we got by using an amp, but on both our ammeters was 0.0172 amps. And it's interesting to know that if we reverse the connection of the ammeter, we'll get the same value but negative. But that can be safely ignored. Again, if you reverse the values back, it just becomes this. The actual sort of magnitude of the value was this. Okay. Continuing our experiment, we replaced the ammeter with a voltmeter, and as sort of expected, because we connected it in series, which is what we were told to do, the current sort of stopped flowing in the circuit. And so this is probably because of the resistance of the voltmeter is just too much. It just stops the circuit, right? This is why we generally connect voltmeters in parallel, not in series. After removing the voltmeter and closing the circuit, we were able to find the potential different changes across specific components. I've sort of marked some of the noticeable ones here. These are across, so A to B, that's just across like both batteries, so that's like the start of the circuit. That's the gain in voltage. But and then across both resistors that we had connected, this is like the drop. And so you'll notice that the sum of these three values here is 0. And I've made a helpful graph here that showcases exactly what's happening with the 47 ohm resistor and the 100 ohm resistor, right? So you see how potential difference ultimately does come back to 0. That's a law, and that law we proved in our experiment. Part 2, right? We made an RC circuit out of 2 light bulbs, 2 1.5 volt batteries, and a 200 millifarad capacitor. And when the capacitor is connected to the light bulb here, it slowly discharges, gradually decreasing the current flowing through the light bulb. And sort of as expected, the light becomes dimmer. It was pretty cool to see this in action. So we connected a charged capacitor to the light and we saw it become dimmer. And that was essentially part 2 of our experiment. We also did this with it still connected to the battery, which sort of had the light bulb get dimmer over time as well. So what if the lab was online? Let's get to the thinking questions. And we had an ideal simulated ammeter. What changes? Well, it has 0 resistance, so more current flows through, and so our values change, likely closer to the predicted values, because again, 0 resistance means it's going to be closer to like the theoretical perfect value that we calculate using formulas. For the second question, right, if we had an ideal capacitor, theoretically it would instantly charge, right? But we know that this is just unrealistic. This is probably never going to happen in the real world, right? But theoretically, if we had a virtual lab with an ideal capacitor with no resistor in the circuit, it would instantly charge. But we never sort of observed that in the real world. And so I hope this was helpful for you. Thank you very much for watching.